Greetings. In this video, I'm going to explain on the axis of symmetry, the domain and range of a hyperbola. In the previous video that I posted on the summary of a hyperbola, we mentioned that there are characteristics of a hyperbola that we need to draw from the equation of a hyperbola. We said that the general equation of a hyperbola is given by the formula y is equal to a over x minus p plus q. We discussed the properties or the characteristics of this equation with regards to the meaning of these letters A, P, and Q. We said A represents the shape. Just to run over that, A represents the shape of a hyperbola, whether that shape lies in the first quadrant and the third quadrant. So we say that when A is greater than 0, the graph lies in first and third quadrants, formed by the asymptotes. Okay, we must mention formed by the asymptotes. We also say that when A is less than 0, which means A is a negative number, the hyperbola lies in the second and fourth quadrants. Hyperbola lies in the second and fourth quadrants, formed by the asymptotes. Formed by the asymptotes. Now coming to P and Q, they refer to the asymptotes. Now the general equation x is equal to P is the vertical asymptote, and the equation of the line y is equal to Q is the horizontal asymptote. Then we went on to say that 3, we can find the intercepts of the line of the hyperbola. We have intercepts, for example, from this graph that we show here. This is a graph of a hyperbola. Now we see that at a point over here, it crosses the y-axis. So this is the y-intercept, the value of the y-intercept, and over here there is the value of the x-intercept. Now what we are going to continue with is now to look at the other characteristics of a hyperbola, namely the axis of symmetry and the domain as well as the range of a hyperbola. Now first of all, let us define what is an axis of symmetry. Well, an axis of symmetry is simply a line that divides an object into two halves, thereby creating a mirror image of either side of the object. In this case, our object is a hyperbola. So we are saying that a line of symmetry is a line that divides this hyperbola into two halves. Okay, when it divides the hyperbola into two halves, then we have got one side of the curve being a mirror reflection of the other. Now, for example, when we look at this hyperbola, I can insert a line here. It's just approximate. Okay, I can insert a line over here. This line will be dividing this curve or two parts of this curve into two equal halves, so that this one side here is a mirror image of the other. In other words, when you put a mirror here, it lies exactly on top of the other curve. Now with a hyperbola, this line that I've drawn here, it is a straight line, but what is important is to be able to calculate the equation of that straight line. What I've drawn here is just an approximate straight line, but now we want to draw the equation of that straight line. There are two straight lines that act as the axis of symmetry. The first one is given as y is equal to x minus p plus q. Okay, so that is the equation of a line that acts as an axis of symmetry. Now what we notice, this straight line, it is in the form, this equation is of course in the form of a straight line, in the form y is equal to mx plus c. Y is equal to mx plus c. Okay, our m here is the gradient of the line. So when we use this equation of a straight line, we are stating the fact that our gradient of that line is greater than 0. If we are going to find the equation of the axis of symmetry with a positive gradient, we use this form of the equation. Now, where is our x, p and q coming from? We get them from the equation of the hyperbola, which is generally y is equal to a over x minus p plus q. So this equation is drawn from the general equation of a straight line. Now when you look at this, because in the exam they really want you to understand and remember and write this equation down. So when you look at this general form of the equation of a hyperbola, y is equal to a over x minus p plus q, which we have written above here. So you will find that this equation here, basically what it does, it is you are removing the a here and just equating the result y is equal to x minus p plus q. Okay, maybe that will help us to remember that. So when you are given y is equal to a over x minus p, so when you just treat like you delete the a over here, okay, then you go y is equal to, then you have to follow the denominator part, x minus p, then you come back to q. So if you follow that route, you'll find that you have come with the equation of the axis of symmetry, which has got a positive gradient. Okay. So that's what we have here. Now, when it comes to the other equation, which is given as y is equal to negative x plus p plus q. That is the other equation. You will also find here that my gradient is the coefficient of x, is reflected in the coefficient of x, the number multiplied to x, which is -1. So this equation here is the equation of the axis of symmetry that has got a negative gradient. So the gradient of this axis of symmetry is less than 0, that is negative. Now this is slightly different from the first one. Two things: my gradient of x is now, my gradient, the value of m now is negative. Okay, here in the first one it was positive, now it's negative, and the value of p is changed to negative p, now it's a positive p. Now how can we remember this equation? Okay, using the same system that we have used earlier to derive the equation, or the first equation here, what you have to do is just to remember how you can come up with that equation. You take your y is equal to a over x minus p plus q, which is the standard equation. But now what we have done here for the second is to insert a negative in the denominator. So nothing has changed except that we have inserted a negative on the denominator. So our equation would look like y is equal to, we said that just cancel off the a, it will be minus x minus p plus q. Now when we remove brackets here, you'll find you have got a negative x, negative by negative, that will give you a positive p, then plus a q, which gives us this equation. So in actual fact, to get the second equation, you just need to insert a negative in front of the denominator of the hyperbola function. So all in all, those are the two equations that we use for the equation of the axis of symmetry. There are two of them. Now coming to our hyperbola here, so you will find that the first line that we can draw is this line here, slanting like that. Okay, we are just estimating that it might be passing through there. Now this line of symmetry, as we said, it divides the hyperbola into two separate parts. Now the other line that we can draw here is a line that would maybe go like that. We could need to go on like that. That will be the other axis of symmetry, so that it also divides the hyperbola into two equal parts. Okay, two equal parts, and one is a mirror image of the other, it's a mirror reflection of the other curve. So this line that I've drawn here is now the one that is the equation of the axis of symmetry that has got a positive gradient. So this line would represent the equation y is equal to x minus p plus q. We know that any straight line that slants from the top right corner to the bottom left corner, that those lines have got a positive gradient. The other one would be the line with the equation y is equal to negative, okay, so insert a negative here, x minus p, then add a q. So that will be the other equation. Now, as you will realize, it depends on what is the value of P and what is the value of Q. So the values of P and Q will determine the exact equation of the hyperbola. We are going to work some examples, specific examples relating to that. Now, so we have explained how to find the axis of symmetry. There are two axes of symmetry. Y is equal to x minus p plus q. Y is equal to negative x plus p plus q. Okay, so now we have got a domain. How do we find the domain of a hyperbola? That is another characteristic, the domain of a hyperbola. Now, what is a domain? A domain is simply the set of all the set of values that can go into a function. Okay, or the set of values. In other words, all the values that can act, that are possible inputs to the function. We know that when we are given the equation y is equal to a over x minus p, so x, the x is the independent variable. So a domain refers to all the possible values of x that are possible to act as inputs into the function. Okay, so that's generally the domain. Now, when we look at our function here, how do we describe the domain of a hyperbola? The domain of a function, in this case our function is hyperbola, is the set of all values of x. So what we have here is when we follow the values of x, we can input an x value and get a y value. Again, x value minus 5, we get a y value, x value, x value. But when we follow the domain, you will find that there is a value somewhere there. There's a value of x where our graph is split somewhere. That line, we remember, it is an asymptote. Okay, that line is an asymptote. In this case, our asymptote is at, this is a 1, 2, 3, 4, 5. So this is on the negative 1. So our asymptote will be x is equal to negative 1. In other words, we don't have a value of the function at x equals negative 1. So negative 1, when x is negative 1, that value is not a possible input. Okay, when we input negative 1, we don't have a value for our function, because remember, the hyperbola or the curve does not touch this straight line. So what we are saying is, you'll find that we can input as many values as we can, but when it comes to negative 1, there's no value for that function. So to define the domain, we can say that our domain is given by the statement x is element of that, which means the x is any real number. Okay, but our x cannot be a p value. Remember, p is the value that is the vertical asymptote. X is equal to p is our vertical asymptote. So x can be any number, any real number. This one stands for real number. A real number, these are positive numbers or negative numbers. Okay, they can be whole numbers, they can be fractions, positive and negative. and any number that you can imagine that is not a complex number, that is not imaginary, is a real number. X assumes any value except the value when x is equal to the value of p. Range, if we said that the domain is the set of all possible values that go into a function, or all the values that we can input into a function. A range is the set of all the possible outputs, okay, of a function. So it means what are the possible values that we get when we put in the values of x. So as you will notice here, we are generally talking about the y values. Okay, x is our input, y is our output. So we put in x, we get a y value. So now what are the possible values of y? So when we are referring to the range, we are looking at all the values of y that we can get. So as far as this graph is concerned, you will find that from y values it goes to negative infinite, and then it comes up, okay? But somewhere here again, we have got a break in our function on that line, that is the y, the line y is equal to q. That is a horizontal asymptote. We don't have a value for that. When we substitute the value of q into the equation, there will be no solution. So that is not a possible output, okay? So we can't get a value when y is a q. So in that case, there is no solution on that line. But after that, then our graph, we end up having we start to see other values as well. Okay, here it goes to positive infinite, and then it goes to positive infinite up there to the right, and then up. So we've got all the values except the values on this line. So how do we generalize y is an element of real numbers, which means y can be any number except the value at q. So y cannot be the value at q. Now, so you find the importance of knowing those letters A, P, Q. They play a role in many cases. One, the shape, the symmetry, line of symmetry, the axis of symmetry. We also find them in the asymptotes. We also find them when we are stating the domain and the range. Okay. So to summarize this, what we are saying is axis of symmetry we have got two axes of symmetry, and then number two, we have got a domain of hyperbola. Now, so all these, the statements that we are given here, they generalize any hyperbola. So what we can change is simply the value of P and Q, P and Q, P and Q. Okay, let's get some examples here. Okay. I have the equation y is equal to 2 over x plus 1 plus 1. Now, from this, we want to find the axis of symmetry as well as the domain as well as the range. Now, for the axis of symmetry, So let's write down the equations of the axis of symmetry. Axis of symmetry. What are these one? So we said the equations will be y is equal to x minus p plus q. This one, first one here. So now we just have to put our p and q. Remember what I said, if you are going to find the equation of, just take that root here like that. Okay, y equals this and plus that, or a minus that. So I'm just going to write it as y equals, I will take that one here, which is x plus 1 plus 1. Okay, just ignore the numerator on top, which gives us y is equal to x plus 2, which gives us the equation of the first line, the one that runs from top right to bottom. Okay, so remember there are two axes, one runs like that, the other runs like that. They always intersect at 90 degrees. So this will be the equation of this one. Okay, now to find the equation of the other one that runs like that one, we use y is equal to, so here there's an x plus 1 in our denominator for the equation. Just insert a negative, multiply by negative 1 there. So we are going to have negative x plus 1, close the bracket, then add a 1. So we have y is equal to, multiply in negative x, negative 1 plus 1. So we are going to have y is equal to negative x. So that will be the equation of the other one, which is the one that runs like that. So it's the line y is equal to negative x. So these are specific examples now. Let's take another example. Okay, let's go, before we go to that, let's go to our domain. What will be the domain? The domain is x, the set of values, possible inputs for the function. We can input any value, real number, but our x cannot be a p. What is our p here? We explained in the previous video that the p in this case is a negative 1. So x cannot be negative 1. In other words, we cannot input the value of a negative 1 into our function. And I hope you can see the reason why, because when we input, when x is negative 1, in this equation here, when x is negative 1, we are going to have a scenario where we have a 2 over negative 1 plus 1. It will give us a 2 over 0, which is undefined. That's why we are saying this input negative 1 is not possible. It's not part of the possible values that we can input in. So we exclude that value. For the range, we are referring to the same equation. The range one, we give y will be equal to real number. Y is an element of real number, but y cannot be a p value. What is our p value? It cannot be a q value. The q value is a positive 1. So y cannot be equal to 1. And the reason why we are saying that y cannot be negative 1 is simply for the same reason that when your y is negative 1, let's just work that one out. This equation y is equal to 2 over x plus 1 plus 1. Now I'm explaining here why are we saying that the y value here cannot be 1, cannot be this one. Because when we substitute it here, we are going to have, let's take y to be the 1, the q, the same value as q. We are going to have 1 is equal to 2 over x plus 1 plus 1. So I'm substituting y with a 1. Okay, so now when you take 1 over to this side, so we will have our 1 minus 1, this will separate, will be equal to 2 over x plus 1, and this will give us 0 is equal to 2 over x plus 1. Now when we try to cross multiply here, cross multiply, in other words, we want to try and solve for x. We have 0 multiplied by that, okay, 0 multiplied by this by x plus 1, we are going to have 0 will be equal to 2, and that one does not make sense. Okay, so it means there's no possible value of x that we can insert here such that we can get it 2 divided by that number, we can get a 0. So that's what we have. That's why we are saying our y cannot be 1. This one we cannot insert it there, we cannot substitute it there. So therefore y is not equal to the q value. The same applies when the q is negative, it will all go the same. The equation cannot be solved, there's no solutions. So that's why we have this. So we can see that when you are given an equation, any equation, we can find the line of symmetry, one line, we can find the other line of symmetry, which is the axis of symmetry, we can find the domain, we can state the range. All of them, we can derive them from the equation of the hyperbola that is given. Let's take another example for the equation of hyperbola. I will take the equation y is equal to negative 6 over x minus 3 minus 1. I want you to pause your video and try to work out this example. State the two axes of symmetry like we have done here, and state the domain and state the range. Okay, take some time to work that one out. After the pause, I hope you come out with the following answers. So let's say you want to find the axis of symmetry. Axis of symmetry. So we said just take that root over here, y is equal to, so follow that root down here to the denominator, which will be x minus 3, and then you go up over here, you subtract 1. Okay, that should give you y is equal to x minus 4. So that is the equation of the first axis of symmetry. The other equation is y is equal to, so insert a negative here, is the negative of x minus 3. So you have a negative x minus 3 and then minus 1. So giving us y is equal to, when you remove brackets, negative x plus 3 minus 1, which will give us y is equal to negative x plus 2. So I hope you have come up with those two answers for the axis of symmetry. Coming to the domain, for the domain, general formula is x is element of any real number where x is not equal to the p-value. Our p-value from the equation is 3. Okay, so x is equal to 3, so that becomes our domain. For our range, y element of real number, and our x cannot be, sorry, our y, because that is a range. Okay, our y cannot be the value of q, which is the horizontal asymptote. Our q here is a -1, so y is equal to -1 is an exception to the possible outputs. So those two will give us the range and the domain. Okay, I hope you found this exciting. Now let's get into some previous exam questions. So what we have here is question 6.2. This is a past exam question. It reads as follows: the function defined as y is equal to a over x plus b plus q, and it has the following properties. First point, the domain is x element of R, and x is not equal to -2. I hope you are getting something from this statement. And the second point, it says y is equal to x plus 6 is an axis of symmetry. So we are given one axis of symmetry. And then we are given the third point, the function is increasing for all x element of R, and x is using for the domain, for the whole of the domain. The graph is increasing. Now draw a neat sketch graph of this function. Your sketch must include the asymptotes, if any. So there are 4 marks for that. So coming to the first point, this one here, x is equal to, x is an element of R where x is not equal to -t. You realize here that this statement is giving us the p-value, because we said that in a domain, the domain can be written in the format x element of real number and x is not equal to p. So if we are equating if we are saying x is not equal to -2, it tells us the value of p is -2. So in our equation here, we can say that our p is a -2. So this statement is giving us the value of p in our general equation. So that's one we need. So we now know that we are answering 6.2. We now know that our p is equal to -2. Now let's come to the second statement. The second statement states that y is equal to x plus 6 is an axis of symmetry. Again, we need to know the general equation of an axis of symmetry. The general equation of an axis of symmetry is given by y is equal to x plus p, rather x minus p, if we consider the one with a positive gradient, because our x here our m is positive. So the general equation of the axis of symmetry with a positive gradient is x minus p plus a q. So what does this give us? What it tells us that the negative p plus q, these two values, minus p plus q, will give us a 6. Okay, let's compare it with the equation here, which is given y is equal to x plus 6. So you'll find that our x plus 6 is the sum of negative p plus q. So what we can say here is that minus p plus q, this value will give us a positive 6. The sum of a negative of p plus q will give us a positive 6. So we are comparing the general equation with that. Now let us now take the value of p. Our p is negative 2. So it means the negative of negative 2, which is a positive 2, plus q will give us a 6. What do we want to find? We want to find the value of q. So our q will be equal to a 6 minus 2, which is equal to 4. Okay, this is a positive 2, take over, you get q is equal to 4. So we now find our value for q. Our q is 4. So we get those two values, which are our asymptotes. Now let's come to the third point. The third point says the function is increasing for all x element of R and x is that. Now what we have here is, let us first describe what do we mean by an increasing function. We said that a hyperbola, we can draw it either in the first quadrant and third quadrant. Okay, that is one case. The second scenario is where we have got our hyperbola in the second and fourth quadrants. When we consider graph A, is it an increasing function? Now, an increasing function is when you take the graph from left to right, when you move in that direction. What is happening to the values of y on the graph? So if I start, there are two pieces of the graph. So when I start on this curve here, so you find that you are moving from a high point, and as you move down the curve, you are actually going further down. In other words, the values of y are decreasing. You are going down. Okay, you can see the arrow, the movement of the cursor going down as you move from left to right. So you are going down. So there's a decreasing function there. When we take the other piece also, we start from left of the graph and we follow as we move to the right. You also find that this graph is decreasing. Okay, you are moving from a high point to a low point. So this graph here generally is a decreasing function. It's decreasing for all the values of x. Now, when we consider this one as we move from left to right, the second option, graph B, when I take the values where suppose you are moving along the curve, so what is happening to the value of y? You are actually rising up the curve, so the y values are increasing. Okay, and then there is an asymptote. Then we come over to the other curve, which is in the fourth quadrant. From left to right, you also see that the curve is increasing. So in this second part of the hyperbola, we'll find that our function is increasing. This is an increasing function. So coming back to this statement here, what is it telling us? When we say that the function is increasing throughout the range, okay, because x is any value, basically it is telling us that the hyperbola is lying in the second and fourth quadrants, because that's the situation or the scenario where we find our hyperbola increasing in the second quadrant, and it is also increasing in the fourth quadrant. Let's come to sketching the graph. Now we are taking into consideration all these points. So to sketch, we have our shape here. Let's take our y-axis, right? And from here, we have got the x-axis and the y-axis. If you still remember here, we have got our vertical asymptote. X is equal to p, which is equal to -2, is our vertical asymptote, and y is equal to q is equal to 4 is our horizontal asymptote. So we are going to insert these asymptotes. X is equal to -2 is somewhere on the left side, so we draw a straight line here. Y is equal to 4 is our horizontal asymptote. We can insert it somewhere here. And now you'll find that we now have the second quadrant and the fourth quadrant, which is formed by the asymptotes. So what it means is we are going to have our hyperbola in that curve, in that quadrant, and another piece in that section. Here you'll find that we are not very particular about the y-intercept because we can't find that one. The a is not given, so we may not be able to show that one in, but basically we have shown our curve, the vertical asymptote, the horizontal asymptote. The horizontal asymptote is y is equal to 4, and we have shown the curve which is increasing in the second quadrant. It's also increasing in the fourth quadrant formed by the asymptotes. So that will represent the sketch of the graph. In another example, we have got this question here. It's also question 6, which is reading as follows. The graph of a hyperbola with the equation y is equal to fx has the following properties. We are given the domain, we are given the range, we are given the point through which it passes. Then we are required to determine the function. Now, as you realize, this is quite an easy question. As long as you know, you can read the information from here. What we know here is x is equal to 5, so it tells us that p is 5. Remember always the domain is x not equal to p, and y not equal to 1, it means q is 1. This tells us q. Then since we are told that it's a hyperbola, so we have to take the general equation of hyperbola, which is y is equal to a over x minus p plus q. That is the general. So we are going to substitute. We know that the coordinates 2, 0, these ones are giving us the values of x and y. So we can substitute y is 0. So we have 0 is equal to a is what we are calculating in this case. A over x is a 2. Subtract p, our p is a 5. Okay, plus q, our q is a 1. Then we can work that one out, which is 0 is equal to a over -3 plus 1, multiply by 3 to eliminate the LCM, multiply by -3, we get 0 is equal to a minus 3, which gives us that our a is equal to -3. So we can now write the equation for y as y is equal to a is negative 3 over x minus p. Put in the value of p, q, and a. So that will be p is 5 and the q is a 1. That will give us the equation. Therefore, our f of x is negative 3 over x minus 5 plus 1. That solves the question.